Sample problem 1. So for an isotropic antenna radiating 100 watts of power, so determine the power density at 100 meters from the source, the power density at 2000 meters from the source, and the electric field intensity for 100 meters. So doon muna tayo sa part A. So the part A, power density at 100 or 1000 meters from the source. So given yung power and yung distance, tinatanong to. So we can use the equation or the formula. So ano ba yung formula natin? So the power over 4 pi r squared, di ba? So again, the formula is, this is for part A, power density. So what is the power radiated? 100 watts. Then the distance is 1000 meter. So let's calculate. So 100 all over 4 pi, the distance. So meron siyang 1000 meters from the source. So this will be the power density, 1000 meters from the source. 7.96 microwatts per square meter. Okay? So ano kaya mangyayari daw sa part B if dodoblehin natin yung distance? So lalayo tayo ng 2000 naman. So same formula ulit. Ayan, so papalitan lang natin yung distance. So dinoble niya yung distance. So let's see what will be the effect on the power density. It will become 1.99 microwatts per square meter. As you can see, nung nag-increase yung yung distance natin from the source, so nag-decrease yung power density. Okay? So that is the relation of the two parameters based din sa formula natin dito. So kapag nag-decrease ito, so nag-i-increase naman yon. Or kapag nag-i-increase to, nag-decrease to. Okay? So they are related based na sa formula. So they are related as ganito. Okay? So ito yung relation nila. So the power density is inversely proportional to the distance na naka-squared. This is actually known as the inverse square law. Okay? The inverse square law. So the power density and the distance between the source and the observer so are related by the inverse square law. So remember this relation. Okay? So letter C, meron pa siyang pinapasolve na isa. So what is the electric field intensity for 1000 meters? So yung power nga natin is 100 watts. So we can use the derived formula for part C. So yung ganito. So the power radiated will be 100 watts. Then the distance is 1000 meter. Yan. So you'll get 54.77 millivolt per meter. So the unit is volts per meter. Okay, so practice using the prefixes such as milli, micro, nano, pico. Okay? So kapag mga ganitong values na yung nakukuha ninyo sa calculator, so use the metric prefixes. So that is the correct way on expressing this answer. Okay? So tama naman itong sagot nito. Kaya lang since maliit kasi yung value, then you can use now the milli na prefix dun sa unit. Okay? Same with this one. Sobrang liit na niya. So kailangan gamitin mo na yung micro to express the answer. Okay? Next, another sample problem. A 500 kHz antenna radiates 500 watts of power. So the same antenna produces a field strength equal to 1.5 millivolts per meter. So if the power delivered by the antenna is increased to 1 kilowatt, then what would be the expected field? So this is field. Nagkabaliktad yung letters. So what would be the expected field intensity? So ang sabi niya, so una, so you have this power, let's say 500 watts. Then yung field strength niya, which is yung E, that is 1.5 millivolt per meter. So ano daw yung magiging field strength if yung power magiging, so this is power 2, what will be the field strength for that power? Okay, so you're going to relate the two. So kapag ganitong problem, so relation lang yung tinatanong, so you can actually use the formula. na meron tayo. So, yung ganito. Yung kanina, yung 30. Yung ginamit natin sa part C, ng problem number 1. Okay, so wala naman siyang nabanggit regarding dun sa distance. So, ang ginawa lang daw, kung 500 siya nung una, tapos 1.5 millivolts per meter yung field strength, so ano yung magiging field strength if magiging 1 kilowatt yung power? So, relation lang ito. So, based na sa formula, so directly proportional yung power dun sa field strength, kaya lang naka-square root dapat yung power. Okay, so using ratio and proportion, you can actually compute that directly. Ayan, so ganyan gumawa ng relation using this relationship. So, ratio and proportion lang. Okay, so what is the field strength 1? So that is 1.5. So hinahanap to. So P rad 1 is 500. Then P rad 2 is 1 kilowatt. So E2, so ito transpose mo lang doon, tsaka to. So kung babaliktad lang siya, so magiging 1.5 to divide. Okay, so the field strength should be 2.12 millivolts per meter. Okay, so since directly proportional kasi sila, ayan. So expect mo dapat na kung nagdoble ito, dapat tataas din ito. Pero hindi rin din siya doble kasi nga square root, may square root ka pa doon. So hindi sila directly na directly. Okay, so they are directly related. However, may square root kasi yung power. Pero dapat expect mo dito na yung sagot mo is mas mataas din sa 1.5 millivolt per meter. Okay, so ito yung eksaktong sagot niya. 2.12 millivolts per meter. Okay? So again, so try to resolve these two problems in your own para ma-memorize yung mga formulas na ginamit natin.